All right, now we're going to do some complex problems involving composite shapes which are made up of multiple figures. Now, finding area, surface area, and volume is relatively simple until you start adding in a bunch of your other geometry concepts, and that's what we're going to walk through. And so we're going to start with finding the area of a composite figure, finding the surface area. This is not composite, but the information is not straightforward. And here's a composite volume problem where we've got a sphere with a pyramid chunk actually removed. And so here we go. By the way, if you can follow along with this, anything else is going to be a piece of cake. So here we're going to find the area. And first I need to identify the shapes within that area. And hopefully you can see there's a half of a circle, there's a triangle, and a rectangle. And so I need to be able to figure out all the different components of this, the area of each. So first let's start with the rectangle. The area of a rectangle is the base times the height. Well, I don't know a height, so that's going to be something I'm going to have to figure out. For a triangle, that is the base, 1/2 of the base times the height, and I don't know the base or the height, so that's something I got to figure out. And for a circle, it's pi r squared, and this is half of that. But again, I don't know the circle either. They don't give me that information. It's all information I have to figure out. So we're going to start piece by piece. And we'll start with the simple one. If this side is 11, then this side also has to be 11 because it's a rectangle, which would leave 6 here, because 5 plus 6, which would mean that the radius of this half circle is 3. Because 3 plus 3 plus 5 is 11. Okay, so we already have the circle, and remember this area of a circle is pi r squared, and this is half of a circle, so it's half of pi times 3 squared, which is, I'm going to say 9 times a half is 4.5 pi. And we'll come back to that because we're going to use our calculator, but we're going to start by just writing in here 4.5 pi. And later we'll round that and use our calculator. Okay, now we'll go to the triangle here, and it's given us, so far it's given us that it's an isosceles triangle, which means that this is 4, and that is 4. And it's given us a 100-degree angle. So there's a number of ways that I could actually approach that. One is by using the law of sines, because I have side, angle, side, so I could use, not the law of sines, the law of cosines. But there's actually a simpler way. If I split an isosceles triangle in half, so that 100 becomes 50 and 50, then I'm making a right triangle here. And now I can just use regular trigonometric ratios. So if I look at the angle, I know the hypotenuse, and I want to know this piece and that piece, because that'll help me solve the thing. So if I've got the hypotenuse, then sine involves the hypotenuse, so sine of 50 is equal to, and I'm going to use some letters here just to make it easy. Let's call that x, and let's call that y. So the sine is the opposite, x over the hypotenuse, x over 4, and the cosine of 50 is the adjacent side is y over the hypotenuse, so y over 4. I realize it's a little small, but hopefully you can see what's going on there. Actually, let me draw that picture a little bit bigger. So this is the angle that's 50. Again, it's half of the original. We've got 4 here. I'm calling that x and that y. Okay, so what I want you to do, I'm going to have you pause in just a second and go ahead and figure out what these two distances are, what x is and what y is. And after you pause right now, next time when we come back, those numbers will be in there. Okay, get to work. Okay, if you use the trig ratios to solve, you would have gotten some pretty kind of crazy decimals here. And that's okay, because that happens a lot with trig ratios. So we got 3.064 and 2.571. And you might wonder why I chose to use so many decimals. That's because when you solve a problem like this, you don't want to round to the nearest tenth or something more like that until the end. Because if you round too short early on, then you introduce errors later on in the process. And so I've blown this picture up just to kind of give you an idea. You can see the triangle there. This piece was 3.064, that was 2.571, and hopefully you can see that, remember that these two pieces are the same because it's isosceles. I basically split it in half, which means that the whole length is double that, or about 6.128 is the whole length. And so let me erase that, 6.128. And now you can see here that we actually know now the base and the height of the rectangle, so you can find the area there. And we know the base and the height of the triangle, so you can find the area there. So it's base times height for a rectangle, and half of base times height for triangle. Go ahead and figure out the area of those. All right, so what I went ahead and did and wrote in the area that you should have calculated for each of these sections, about 67.4, about 7.88, and we still have our 4.5 pi. And then I use my calculator to add up all three of those together, all three sections. And then I round to the nearest tenth, and I end up with a total area of 89.4. So again, sometimes it can be complex to solve each individual one, but once you find the lengths and the sides you need, it's just calculating the area and adding it together. Relatively simple. The complex stuff is the stuff you learned previously. All right, now we're going to find the surface area here of this pyramid. Now, on a pyramid, you need to find the lateral area as well as the base. The lateral area, the formula for the lateral area is 1/2 perimeter times the length of one of the sides. And then the base area is a triangle in this case, and sometimes it's a quadrilateral, it could be a square or a rectangle. The base area in this case is 1/2 base times height. And so we're going to go ahead and look here. Sometimes it's difficult to tell in these three-dimensional figures what's going on, but in this shape, I have a right angle here on the base. And so I've redrawn the triangle base right here so you can see exactly what's going on. So we're going to start with the base area, and then we're going to do the lateral area, because if you can see, we're asking for P is the perimeter. That's the length all the way around, and I don't know that piece. I don't know that piece right now. Okay, and I'm going to need to figure that out. So looking at this triangle, I need to figure out that length in order to find perimeter. But before I do that, base area, that's really easy to calculate, because that's just 1/2 base 7 times 5. So 1/2 times base is 7 times 5 ends up giving you 17.5. Okay. And then if I want to find the length here, well, that's the Pythagorean theorem. That's a squared plus b squared is c squared, where c is the hypotenuse. So here we go. We got 7 squared plus 5 squared. That's 49 plus 25. Add those together and I will get 74, and then I take the square root. So this means this is the square root of 74. Now, when you add these all together, 5 plus 7 plus square root of 74 for your perimeter, that's something to use your calculator for. A lot of these problems you're going to end up using your calculator. That added up, all these added up, 5 plus 7 plus square root of 74 is the perimeter of my base, and that's what I plug in there. Now L is the length down the side, and it tells us right now that that's 10. So I want you to go ahead and figure out not only what the lateral area is, go ahead and add these all together, plug in the number you get here for perimeter, and then 10 for L, but then also add it to the base area to find the total surface area. So the total surface area, you got to get the lateral, every side, so lateral and base. So go ahead and do that. When we come back, there'll be an answer. Okay, so if you would have followed along and found the lateral area, you would have come up with 94.7. Added to already the base area of the bottom triangle we already had, and that comes up to 112.2. Now, let's do this problem. Find the volume. In this picture, it's sometimes really hard to draw some of the complex shapes in geometry, so I'm going to do my best here. This is a sphere with a pyramid. This green pyramid is sort of cut out. It's a hole inside of the sphere. And if you see, the pyramid comes out of the center. That's why there's a dot drawn there as best as I can. Coming out of the center with a radius of 5. And it also goes from the center perpendicular to that top face straight down to the bottom of the circle. So we got a radius of 5. Since this goes from the center to the down to the bottom of the circle, that also must be 5, because the sphere, because every distance from the center is the same in a sphere. And so this distance going down must be 5. Since this is a radius and this is also a radius, that's also 5. Okay? And so what we're going to, one more thing. This is, as you can see, since this is isosceles, this is 5 and 5. That means that this base angle and this base angle are the same. So these are both 45. And let me draw the picture of that triangle here. That's 5, 5. That's 45, 45, which if they all add up to 180 leaves 90 left, which means that this is a right triangle. So this is the top face, and then it comes down to a pyramid underneath. Okay, so that's kind of an explanation of the shape. That's the most difficult part oftentimes about all of these problems, is understanding what the picture is actually saying so that you can come calculate. After that, once you understand what the picture is, it's actually relatively simple. We want to find the volume of the whole sphere and then subtract out the hole in the middle. So we're going to use a volume formula for a sphere, which is 4/3 pi radius squared, and our radius again is 5. So our radius here is 5. The volume of a pyramid is 1/3 times the base area. Remember that B stands for base area. And here's our base. Remember the base is that triangle. That's this right here. And you can see we have a right triangle, so we can actually calculate the area using this as our base and this is our height, or vice versa. And then the height of the pyramid, which is the perpendicular height, which we already know is 5. So h is 5. The base area here is 1/2 5 times 5. So I'll write that there, 1/2 times 5 times 5, because it's 1/2 base times height. So I got a bunch of numbers up here, and I want you to figure out the rest. You're going to take the volume of the sphere using this formula and a radius of 5, find out what that is as a number, and you're going to take away the empty hole of the pyramid using this, where your base area is the area of this triangle, and your height is 5, because that's given there in the problem. Okay, go ahead. If you can get this one, I think you're good to go.